All right, good morning, class. I am not here presently, so I will be speaking to you through the power of the internet. Unfortunately, Dora the Explorer was not here to help, so I will be doing this by myself and pausing and saying that's right as we go along. So let's get to it. All right, first off, for going over your worksheets of the vocab words, we first have the igneous rocks, which once again are rocks made from cooled magma or lava. And these are some examples. We have some lava, lots of lava, and a volcano right there. So for first period, we just barely got to talk about what intrusive versus extrusive rocks are. So intrusive rocks, once again, are rocks that form down below. So right there. So right here are where the intrusive rocks are. They form below the ground. And extrusive rocks form out here, where lava flow comes down. And once again, extrusive rocks are rocks that form on top, or intrusive rocks form on the bottom. Now, intrusive rocks, because they're formed under the earth, they have a lot longer time to cool. And because of that, they have a lot more time to form their crystals. And so intrusive rocks, ones that form under the earth, have those wonderful coarse-grained crystals that we're going to see much more in the rock samples we'll be talking about next time. Where extrusive rocks, because they're formed on top of the earth, they cool very quickly, and generally they do not have time to form those beautiful crystal structures, so they have very fine-grained crystals. Or sometimes they just form obsidian, glass, where they just don't have time to form crystals at all. So once again, intrusive rocks are ones that form at the bottom, under the earth, and extrusive rocks form on the surface. They cool, like extrusive rocks cool quickly, and as a result, these rocks are fine-grained and lack a crystal growth. They're very fine-grained. You can't see the crystals. Where intrusive rocks, you can see the crystals because they are formed from magma that cools slowly. All right, what is phaneritic versus amphoreitic? Go ahead and answer those two questions. Go ahead, substitute, pause the video, and we will get to the answer presently. All right, so hopefully you've given some wonderful answers, and we'll go through the answers right here. So phaneritic means that the crystals are visible to the naked eye. They have large crystals that are big enough that you can actually see them. Now, these large crystals, once again, are very large. They are generally formed from intrusive rocks. And so you can connect the phaneritic with intrusive rocks. Or aphanitic. Aphanitic means that they are not visible to the naked eye. The crystals are microcrystals. They're fine-grained. They're too small to see. So aphanitic and phaneritic. Phaneritic means they have large crystals that are visible. Or phaneritic just basically means it has crystals that are large enough to be seen with the naked eye. Where phaneritic, or amphoreitic, means that they're too small, they're too fine-grained for us to see with the naked eye. And once again, amphoreitic and phaneritic. Amphoreitic, they cool rapidly, form small crystals. They are very fine-grained texture. They are very much from extrusive rocks. They are formed from extrusive rocks that are formed on top of the earth. Where phaneritic, they cool much more slowly and form large crystals. They're referred to as coarse crystal grains, and they form intrusive rocks. So go ahead and take a minute and write all that down if you haven't already. And then we'll move on. All right, the next one we have is pyroclastic rocks. Pyroclastic rocks are what? Go ahead and answer this to class. Pause the video, and then we'll go over what they are. All right, pyroclastic rocks are rocks that are formed by volcanic ash, or things that explode out of volcanoes. They are pyroclastic because they are like pyro stuff that is classed together. They are they are ash, debris, stuff that becomes cemented together. And even though they're kind of somewhere between, they're generally considered igneous rocks, even though they are a little bit sedimentary rocks. So pyroclastic means formed from volcanic ash and debris. All right, vesicular. Vesicular means what? Go ahead and pause the video and have students answer. All right. Vesicular refers to the word vesicles, which means containers. In this case, the little bubble marks you see all right there. Right here, we're seeing this beautiful piece of vesicular basalt. And vesicles are rocks that are formed from lava cooling rapidly, and all those little permutations are from bubbles in there. So vesicular refers to this bubble rock. So you could say vesicular, you could write this down and say that vesicular refers to rocks that are bubbly in texture, not in personality. Vitreous. Go ahead and answer. What does vitreous mean? All right, vitreous means that the material is glassy or has this glassy sheen. You can also see all these wonderful conchoidal fracture breaks right there. Now, what's an example of a vitreous rock? A vitreous igneous rock. Go ahead and pause for let students answer if they haven't already. And the example of vitreous rocks is obsidian. Yes, it's obsidian. Obsidian has a beautiful example of glassy texture, which brings us down to sedimentary rocks. Now, once again, going over the themes, I do want you to be writing down whatever answer will best remember. A lot of you copy down answers from the computer that are very complex, and I want you guys to be understanding these on a personal level. Because if you don't understand these on a personal level, it would be really hard for you to talk about them and explain them. So I do want you to, if you need to, rewrite these questions, rewrite your answers so you can actually explain what's going on here. All right, sedimentary rocks. They're rocks that are made of rock fragments that are cemented together, compacted together. They can come from rock fragments, dissolved minerals, biological remains, but they are pieces of other pre-existing rock that are broken up and then recombined and cemented together. All right, now we have bedding planes. Go ahead and answer this Discuss. Pause the video if needed. All right. Now, what bedding planes are layers or planes of rocks, rock layers that get deposited. They can be different types of rocks. They can be the same, but you will distinctly see that layering pattern, just like on a cake. You'll see layers like an onion or a cake or, well, other things have layers. A lot of things have layers. But those are deposited from different environments or the same environments, but they are deposited from distinct different times, either from different environments or the same environments. Bedding planes are layers of deposition that you can clearly see in the rock layer. They are layers of deposits. And this is an example of cross-cutting layers, bedding planes. This is in sandstone. This is an example of, what is this? This is an example of dune formation. Actually, no, this isn't dune formation. This is stream bed. This is actually a stream bed cross-cutting for rivers when the river slightly changes its course a little bit. And then here you can see example of just all the different types of rock layers. Now, banding. Banding is different from rock planes or bedding planes because bedding planes are actual depositions. You get like a layer of sand and maybe another layer of sand and a layer of limestone, etc. Where banding planes, it's all actually just one rock. It's just got striped. It's one type of rock. It's one layer of rock. It just got striped. And so you could say banding is striping on a rock that's caused by water or other natural forces. So these red lines you can see are from oxidation. All right. Fissile. All right, go ahead and answer what is fissile and pause the video if necessary. Fissile means it breaks in sheets. In geology, fissile means it breaks in sheets. So that's why I have this lovely sliced cheese right next to it. So because with fissile, like you can see the slate right there, and those are break in fissile ways. So fissile means it breaks in sheets, and you can easily see how it's breaking apart in those sheets. Now this covers the 3 different ones of the planes. You have the bedding planes, which are the planes of bedding you can see. You have the banding, which is striped that would come after the rock was deposited, after it's rock. So bedding planes would be deposited when the rock was made, and banding would come afterward. And fissile is when it's breaking apart, if it's breaking apart in layers. And all of these can exist in the same rock. Not all of them have to. They can exist in multiple rocks. They can just have one of these properties, but these are the 3 ones that are kind of hard to tell apart. And so I want you to be able to think of a way to keep these straight in your head. All right, we'll just go ahead and give you a minute there to think and write things down if you haven't already. But now, what does phospholiferous mean? Pause the video while people talk. Yes, phosphoriferous means it's made of fossils. And that's basically it. It just means the fancy word that says it's made of fossils. Clastic. What is clastic? Clastic means that it is made of what? Go ahead and pause the video while students answer. Okay, clastic means it's made of little bits of other rocks. You can see on this one on the right, the conglomerate, it has all these lovely little, give me a second. There we go. It has all, oh wow, that's a terrible thing. All right, right there. It has all these lovely little cobbles and pebbles and not boulders, not big enough, but it's made of all these individual grains of rock. The last one, phosphoriferous, it was made of fossil, but this one, it's made of these actual clastic, these other rocks. And so that's what clastic means. It's made of other rocks. And so right here, you can see individual grains on the left. If this was cemented together, it'd be a clastic rock. Go ahead and give yourself a minute to write all that down. All right, mud cracks. What are mud cracks? Yes, mud cracks are just mud cracks. They're just cracks in mud from the drying out. And these are examples of surface structures that can be preserved. Like here on the right, you can actually see where the mud cracks used to be. This got filled in. And this is an example of fossilized. And we use these to find out what environment it was. All right, one other really common surface feature is ripple marks. We're going to experience some ripple marks in the lab next time. And these kind of show you, the direction and the turbidity of the water current. So ripple marks. All right, and the last category is metamorphic rocks, rocks that form under heat and pressure. And the only 2 definitions for metamorphic rocks is being foliated or non-foliated. Foliated means that they have these, what does it mean? Go ahead and answer that. Pause the video and answer that. Okay, foliated means it has these wonderful, lovely striping patterns, these layers. These layers can be straight. They don't have to be. Oftentimes they are smushed from the different differential forces. And that's what they talk about, how like there's differential forces, and those unequal forces will cause them to become squiggly like this. That is not a geologic term, that is an Eric term. They become wavy and squiggly. And like the other, and so they can also be straight, like this one right here. And so the two main differences of metamorphic rock are foliated and non-foliated. Now, foliated rocks are rocks that have layers, and non-foliated rocks are rocks that do not have layers. And how foliated rocks get their layers is because of cooking under the earth. Generally, the more time they are subjected to, the longer and more opportunity they have for the material to separate. Just like it does in the earth, how like the different materials separate into different layers. Just like if you leave muddy water long enough, it'll separate into different layers. Foliated rocks, when they're subjected to heat and pressure, eventually the different layers are squeezed from each other and form these beautiful patterns. So these are the two basic ways you identify metamorphic rock is foliated and non-foliated. And then we're going to go ahead and answer a couple questions. Go ahead and take, let's say, 6 to 7 minutes, and answer these questions. What features are easy to mix up? How can you make sure to keep them straight? Were any of these vocabs harder to find than others? And were any ended definitions that surprise you? And do all these, and then last of all, this is a thought one. Go ahead and write a couple sentences for this last one. What do these features tell us about rocks? Go ahead and pause the video while they work on that and discuss afterward. All right, moving on. Now, after you finish all that, we're going to talk about two more things before we get to the lab tomorrow, and that is grain size. So we've talked about coarse grain and fine grain a lot in these videos. But what coarse grain means that it has large or visible crystals or granules. In igneous rocks, those crystals are visible to the naked eye. They're phaneritic. You can see them, and if they broke them up into pieces, you could actually feel them pretty well. With coarse grain, with sandstone and conglomerate and other sedimentary rocks, coarse grain refers to them being coarse enough that you would actually feel. So if you get a piece of sandstone and rub it between your hands, you'll feel coarse grains get out. And then on the other hand, we have fine grain sandstone, fine grain rocks. Fine grain rocks can refer to either the crystals or granules again. And they are granules that are too small to see. If you looked at the rock, you wouldn't be able to see the individual granules or crystals. And if you rub them, you just feel powder or maybe a soft, maybe you wouldn't feel anything. But generally with sedimentary rocks that are fine grain, you don't actually feel individual grains. Whereas with the coarse grains, you will definitely feel individual grains. You'll feel like you can say, okay, I can feel the individual grains rubbing against it. And that's the difference between coarse grained and fine grained.